My name is Vishnu Gare. I'm a third year in electrical and electronics engineering students in University of Greenwich, and this is a small presentation about my final year project.
Well, essentially, the main object and aim of this project was to design a integrated energy harvesting system for the electric vehicles, which can provide the electricity for the lighting system of the vehicle. And the second part was to build a switching circuit, which can switch the circuit to the vehicle's battery when the harvested energy is not enough. In order to carry out this project, I have selected a wind turbine technology to go forward. As shown in the figure here, this is my wind turbine, and that wind turbine is kept inside the grille of the vehicle. And just before you jump into any questions, yes, I have considered the drag factor very seriously and done my mathematical analysis. And if you see the formula over here, it says this is the formula for the force of the air drag, and it turns out that doing this does not actually add up the air drag to the vehicle, because I have done analysis of each of these individual parameters, and adding this wind turbine to the grill does not affect any of these parameters at all. Hence, I'm going to go forward with this project and make it work. So, as I mentioned earlier, this is the wind turbine, and it works on the electromagnetic induction theory. So this is my DC motor. What the DC motor does is it changes the mechanical energy into the electrical energy from the wind turbine. Then this wind turbine is made out of the 3D modeling in CAD, and I basically just printed them using the 3D printer in my university. So what it does is every time air hits it rotates. It's the aerodynamics of the wind turbine, and it rotates the rotor inside the motor that creates the electricity, and the created electricity from this motor is connected to a buck boost, a DC to DC buck boost converter there. DC to DC buck boost converter, it works as a step up or down regulator, a step up or down converter, or the regulator as well. So this is the small DC to DC converter. The reason why we use this here is to change the voltage that's producing from the motor to 12 volts, which is the necessary voltage for the lighting system. And this DC to DC converter is manipulated using a simple potentiometer on this one as well. Um, from well yeah then This is my second part of the circuit, which is the switching circuit, and this is my SPDT relay there. I've used SPDT relay to do this process, and this is my positive voltage and my negative voltage coming out of the buck boost converter, and they're connected to the breadboard of that circuit. And this SPDT relay has a coil. If you see these two pins over there, those are the pins for the coil, positive and the negative, and they're connected with the output coming out of the buck boost converter, and this is the normally closed terminal. That's normally open terminal, and normally closed terminal is connected with the vehicle's battery, and the energy we harvest in here is connected to the normally open terminal. So what happens is that whenever the energy produced by the buck booster is enough to energize this coil of the SPDT relay, then the energy is passed through this one, and there is a LED connected to the common point representing as a lighting system, and it will stay on. But if the voltage is not enough to energize that coil, then it will stay off. It will have a supply from the vehicle's battery itself, because it's not enough. And this SPDT relay, that's how the SPDT relay works, and this is my circuit for it. Well, moving on, after all the circuitry was built, now it was time to I do a testing. Hey, the testing is the most fun part though, isn't it? Now, to have a little fun, I get this turbine a little housing, with the bits and pieces around, I found around my houses, and I basically kept all of these my breadboard inside this one. It's actually covered, and this is the other breadboard. This can also be covered like this, making it like a more professional, so that the user only can see this output from there and the wind turbine from on the front. That so in order to carry out the testing, I've connected the output of the buck boost converter to the multimeter here to see what voltage I'm producing at what RPM, and I've used a tachometer to measure the RPM of the wind turbine here. If you can see, there's a white reflected tape there and the red thing there. That means it's actually just measuring the RPM of that place particularly. So while measuring, this is the RPM, that's 1265, 1232, and I'm getting about 12.2 volts output, which was the intentional, which was the expected output, because a vehicle needs a 12.2 volts for the lighting system, from my research earlier, and this system will only produce 12.2 volts. It is not going to produce any less than that. If there's no 12.2 volts, then it's zero voltage. Having the electricity supply from a different from an electric vehicle's battery, but not the harvesting system. This helps in keeping the regulated voltage for the lighting system to work. Well, now to do a current measurement, I basically taken off all these breadboards from my little housing. Yeah, well, it's because I had to use a load to measure the current, and it was a bit hard to put a load inside the boxes. So this is here I've used a LED as a load in here, and I'm measuring a current. As you can see on the multimeter, it's about 30 milliamps, 29 milliamps right now. Well, obviously this is actually kind of good amount of current, but it's not as good as we expected or we need for the lighting system, which is quite higher than this one. Thinking that way, it's kind of disappointment, but it's still a good thing. It was a concept, and I think this proves the concept very well, and I believe that if we were able to use the higher rated motor like 12 volts 5 amps, then we'd probably be able to produce the enough power for the lighting system anyway. And this here is the graph of my outputs against the speed of the vehicle, to see that there is a voltage and a power. It looks good. Thank you very much. Thank you very much for listening, and happy day. Bye.